Hello, Count Sacke here, back with another Genshin Impact video. Today, I'm just going to mainly respond to a few comments relating to my proof for the optimal crit ratio and whatnot. Now, I probably will have to split this into two parts because this first one is honestly kind of long. This first part will mainly cover the how the crit rate and crit damage and crit value are related to my proof. And in fact, I'm going to show how my proof can be simplified into a much simpler proof. But I also want to show another thing in this video, and it is how the equations I'm showing here on screen, CRI is equal to NRI CV, and CDI is equal to 2 times NDI times CV, and I want to show how those equations specifically relate to how the artifact system works. So that way, when we are able to show that the artifact system reduces to this much more simpler equation, we can be confident that my equations didn't just come from nowhere. So in short, this video is mainly about derivations, and it's going to show proofs on how everything is connected. But as I said, there will be a part 2, so be sure to subscribe so that you don't miss out on that one. Also, make sure to like, share, comment the video. You can also support the channel by becoming a channel member where, you get the following perks shown on screen. Lady Zubai is very happy, by the way. She's very proud of what you all have done. Thank you so much for all the support, by the way. So yeah, anyway, enough about that. Let's get started. Let me go to Paintel Sai. Alright, so let's go ahead and get started with the much simpler proof for why the optimal crit ratio is 2:1. I'm just going to start off by writing out our equations, which is that our damage is proportional to the average crit, and obviously this is the thing that we specifically want to optimize. Now, of course, we can't just optimize this, like, take a derivative, set it equal to 0. We have to specifically impose a condition for that to work. So what exactly is our condition? Well, it just so happens that there's a lovely equation that a lot of people like, and a lot of people are just willing to accept it, by the way. But anyway, you have this equation that's CD plus 2CR, and that is specifically equal to the crit value. This quantity right here is called the crit value, and we specifically force ourselves to have CV be constant. That is the most important assumption about this proof. Now, from here, this will be our constraint. The next thing we would want to do is find the optimal values for everything. So what we do is, well, we could use the method of Lagrange multipliers, but there's actually a much simpler way, and it happens to be because this is a very simple problem. This equation for the average damage, by the way, is a multivariable function. It has two possible inputs that we can tune. However, these two inputs are related by this equation. So we can essentially just substitute for one of these values for either crit rate or crit damage, and then reduce it to a single variable problem. And the way I'm going to do that is by substituting for crit damage. And the way we do that is by, first of all, we're going to isolate CD, so we can subtract 2CR to both sides. And then we just take this expression and plug it into the value for CD. And there we go. Hopefully now you can see that this is actually just a single variable function now. Damage only now depends on crit rate. So what we can do now is take the derivative and set it equal to 0. Now, we will specifically set the derivative of the average damage to 0, so that's why I'm going to write a 0 here. Next, well, as you know, we can actually just distribute the derivative into all of the terms here. So this alpha here is a constant, so we could just factor it out, in which case we will be left with something much more with something like this. The derivative of 1, well, that's a 0, so we have a 0 here. The derivative of CV times CR with respect to CR, well, the CV is constant by our constraint, So that will be factored out, and then you'll be left with the derivative of CR, which will just be equal to 1. Lastly, we have the derivative of this term. Well, we can factor out the 2 here, so we're going to have a 2. And then we have, well, CR squared. So we can make use of the power rule, and we'll arrive at 2CR, and that's raised to the first power. Alright, so now we can simplify things just a little bit further. And, well, we can essentially just divide both sides by alpha, so we can get rid of it. And 0 divided by alpha is 0. And then we can just ignore the 0 as well, ignore the 1. And what we will see is that we can also combine these 2's here to be a 4. And we have a minus. Or you know what, I'll write it out more explicitly. So we have CV minus 4CR. And what do you know? This will specifically tell us that our crit value is 4 times the crit rate. We also know that our crit value is related to crit damage in some way. Well, it's from this equation, so if we take CV here and put this 4CR into that, well, we'll be able to express crit damage in terms of crit rate. And, well, 4CR minus 2CR, that's just 2CR. And what do you know? You'll manage to get the crit damage to crit rate ratio all over again. So we have CD divided by CR is equal to 2. So, for those who are wondering why I did not present this proof, I'll be honest, I did know about it, but it just never convinced me. Now, the reason why that is, even though many people have tried to explain it to me in the comments, it all goes to this equation right here. Why this specific equation? Why? And I think that's just the problem I have with any sort of proof that involves crit value. Why do we specifically need to assume this equation? Why don't we assume some other equation? For example, well, if we want to hold our crit damage and crit rate stats, we could just, if we want to hold them constant, we could just say that this is equal to a constant. And yeah, we can now allow ourselves to completely change crit damage and crit rate freely. Now, of course, some people will tell me immediately that the 2 is there because, you know, crit rate, because of the minor affix values, you know, the 2.7 and the 5.4. There's also the 3.9 and the 7.8. Yeah, those people will tell me that that 2 is there because of that. Granted, they are justified, but I just don't think it's justified well enough. And that is why I ended up doing the proof I did. So, now, let's take a look at my case here. What did I exactly do? Could use CVI here, but technically speaking, because we're only considering like crit stats and whatnot, and you know, everything is kind of related, you could just use one single value for this CV. And another thing to note, this is not crit value. It is an unfortunate notation on my part, and I apologize in advance for that. I will specifically let the capital C with a subscript V be the crit value. When I refer to this lowercase c with a V, this will be what is known as the common value. So that's a little bit of an unfortunate notation I have decided, but well, sometimes you just gotta do what you just gotta do. After all, I called it common value, and well, what would I think to, you know, notate the 2 CV? Yeah, that's a little unfortunate. So, you know, when I actually specifically wrote my equations that NRI and DI are specifically held by a constant capital NI, this thing should somehow be related to, well, this one. And well, they are in fact related. It's just that you need to do a little bit of work to get there. And I think that this is a much better way to prove it. And it is this. you specifically take the NRI, and then you will actually solve for them. So we have NRI, we divide both sides by CV. Then you have NDI, well, you got CDI, and you divide that by 2CV. And then all we gotta do is to substitute them into this equation here. Now, one last thing. We can multiply both sides by 2CV, and we'll get a very interesting relationship, which will be CDI plus 2 times CRI is equal to 2 times NI CV. Well, this equation looks particularly familiar. In fact, it is literally just the equation for the crit value, but notice that we have some index i's here. This means that it pertains to the ith artifact piece. And you know, the different artifact pieces a character can have are the flower, the plume, the sands, goblet, and circlet. So the I is just to represent that it could be any one of those 5 different pieces. Now, here's the thing. This only pertains to the artifacts. But we want to essentially show that this works for the overall character's crit rate and crit damage, not just the artifacts, because, well, actually, if you only consider the artifact, minor affixes, might I add, that would result in a non-optimal, average damage. And the way to simply account for that is that there are non-flexible values of crit rate and crit damage. And those are specifically accounted for by what we'll call baseline values, which are CR0 and CD0. And let's go ahead and actually write out the full equation for our crit rate and crit damage. We can essentially now combine them together in a manner that is very similar to this. But, we'll take CD plus 2CRI, or CD plus 2CR, that is going to be equal to some total crit value. And if you substitute, well, we can actually distribute this 2 into the different terms here, and then we could group the summation symbols together. So this term here, that looks like a constant. And well, yeah, that is specifically the crit value from the non-adjustable parts of your build. So yeah, that's very interesting. And I specifically, when I say adjustable, I'm referring to the minor affix values of the artifacts. So everything that's not those, as far as I could tell, I haven't seen anything that doesn't fit into these that aren't the minor affix values. So yeah, those are what those are. So essentially, when you hold this thing constant, well, by definition, this one is also a constant because these are fixed values. This one must also be held constant. So that is how all of this connects back to this much more simpler proof of the optimal crit ratio. So for the next part of this video, I want to elaborate on where exactly this 2 comes from, or in fact, where these equations come from. So, as you might know, in an artifact, the minor affix values can essentially have 4 different possible values. For the crit rate, you could have 2.7, and this is all in percentage, by the way, 2.7%. You could also have 3.1, 3.5, and lastly 3.9%. I'm going to arrange them by specifically into specific tiers. So we have tier 1, tier 2, tier 3, and tier 4. So tier 4 is the best. and tier 1 is the worst. But for crit damage, we will observe that these minor affix values are 5.4, 6.2, 7, and 7.8%. These are 100% observable facts. You cannot deny that these are what exist in the game. What I'm going to do is to essentially, well, model an artifact exactly as they appear in-game. So, as you might know, when you have any specific artifact, you could have any one of those tier values for the starting value of the crit damage and crit rate. However, when you actually go ahead and upgrade them, so I'll just do this for example. So if I upgrade this to, if we upgrade this to level 4, well, it went to energy recharge. Let's try this again. Wow, okay, this is just the experience of all time. Please. There we go. You can notice here that we went from 3.9 to 7.8. We actually got very, very, very lucky here, because let me go back to our Paintal Sacke here. Because, essentially, for our crit rate, we ended up getting this twice. So, notice that these are very discrete. You have this, we have either 2 of this, we have 1 of this, or you could have 3 of this, and so on and so forth. And it just so happens that if I happen to get lucky every single time, you would start with, you would start with the base value, which is 3.9, but then, if I reach level 4 and it upgraded by 3.9, well, then I would now have this by times 2. And if I go to level 8, that will be times 3, then 12, 4, if I go to 16, 5, and then 20, 6. So essentially we have a quantity, I'll call this M, so the MR, and I'll call them MD. These are quantities that can range from 0 all the way up to the number 6. So that's pretty cool. The next thing that we have to consider is how we're going to model this specifically for the ith artifact piece. So what is the specific crit rate stat for the ith artifact piece? So let's go ahead and go back into the game and see what's happening here. So in this, we specifically have 2 times of this value here. But that value could have upgraded by a different tier value. So I essentially just need to multiply every possible tier value with the respective M. That M value is just an integer. It just tells you which tier was selected and how, and yeah. So essentially, we could have 2.7. That's one of the possible ones, and then I could do MR1 for the first tier, and then the ith artifact. Then we'll have 3.1 like this, 3.1 MR2 second tier ith artifact. And then we can do the same exact thing for our crit damage. So this is how we will be able to model the crit rate stat on the ith artifact piece. So in the case of, the example I was showing here, so we have 6.2, and if we go back to our Paintal Sacke, well, we would just have this one be a 1. And then for the crit rate, it was a pretty nice one, which is this will be equal to 2. And if there were other ones, this one could be a 1, and this one could be not like that. Yeah, you just change their values from 0 to 6, and that will give you the crit rate and crit damage of any possible combination that you could possibly have them in. So, of course, these equations alone by themselves don't fully model the system. You still need to make sure that the sum of these two actually reach 6, or, it depends on what level your artifact is. So, yeah, that's important. But for now, I'm just going to focus on these equations here. Now, if you're wondering, why did I choose to arrange them in this way? well, granted, if we take every single possible value here and multiply them by 2, you will get these values. And that's really, really, really cool, because that essentially allows us to essentially do this. So CDI will be equal to 2 times, well, now, so that's really, really, really cool here to see here, that there is a way to essentially make these two look pretty close to each other. They look almost, well, they're not identical, but they have a very similar form. Now, yeah, from here, what we can do is that, well, I'm going to kind of simplify our notation here a bit. I'm going to let CV1 equal to 2.7. I'm going to let CV2 be equal to 3.1, and hopefully you'll see the pattern by now. So this essentially allows us to write out our equations in a much more simpler manner. So, or at least it's simpler in the sense that I don't need to write specific numbers. Alright, so yeah. And now I'm just going to make use of a notation that I have used in the past to greatly simplify things. And well, it's a pretty standard mathematical notation. Just so you know, this will help make reducing the amount of writing. This will help reduce a lot of the writing. So rather than writing every single individual term out as I have done, what I'm going to do is have it such that I sum over all of the different possible values of j. So, you know, j can go from 1 to 4. So what is this j? It is going to represent this index there. There's two indices. There's this first one here, and then there's the I. So the number that comes right before that I is representing the different tier. So, you know, CV1, well, that refers to the first tier. CV2, second one. CV3, third one. CV4, that one. So because of that, I can essentially compact all of this into a very, very beautiful and very simple, notation, which is this. MRJI. Well, okay, let's try it. So we have j is equal to 1. Well, we get this term. Then we have to add that with j is equal to 2. Well, that gives us this one. J is equal to 3. There we go. That one there. J is equal to 4. There we go. And that's what this notation is. That's how I'm relating the two. And the next one is for crit damage. Well, we have this 2 here, so we can't forget that. And then we can multiply that with the sum. So yeah. We're getting close to our desired equations here, because we want to get these ones. What I'm going to do now is define a common value amongst all of the different possible tiers, or all of the different possible minor affix values. You could let this common value be anything. It could be 2.7, it could be 3.9, you could let it be 7.8 if you really wanted to. You could let it be the average of these values, you could let it be a negative number. The only numbers that this common value that I'm going to define is that they cannot be equal to 0 or infinity. But for simplicity and making it relate back to the game, we could just let it be this 3.9 or this 2.7, or in fact, it could be the average of all of these values. But for me, I'm not going to explicitly choose. I will specifically define a relationship where I'm going to say that kj is specifically the value, the common value on the jth tier is equal, so we take the common value from the jth tier and divide it by a overall common value, a universal common value, if you might will call it. And this kj, well, it's actually just the ratio of those two. Like, I think this one is like, is it 9%, like 9, 8, and this one's like 7% of this one, or 70%, sorry. These are essentially constants, and we'll have a constant k here. And anyways, we can actually simplify this just a bit more by taking the advantage of the fact that CVJ is equal to KJ times this shared value. And what do you know? We have this CVJs there, so let's go ahead and substitute for them. All right, the next thing to do in this is that we have to recognize that this CV, it does not depend at all on this summation. So we can, and it is found on every single term, so we can essentially factor it out. And well, if we take a look at the expression they produce when we do this, it'll actually look really, really, really familiar, and it's going to be really cool when you see it. These equations, they should look a little bit familiar, don't they? The thing is, this quantity right there, that is equal to NR. So, we now have figured out what NR and ND, or at least NR and NDI are. So, let me go ahead and write them out. So yeah, that's what we can now see from this. We can now see how everything is related and whatnot. Now, I'm just going to bring up a specific comment by Lewis Who 8214. They actually specifically had a problem with the way I did my proof. And it comes down to the fact that I've assumed that this 2 is here. That's basically what it comes down to, but it's a little bit more complicated than that, because he's actually claiming that because I'm actually specifically matching tiers here. So it's like, you know, I decided to group this in a very, very, very specific manner. Why couldn't I just call tier 1 this, for example? That's a very, you know, that will be a very interesting problem. And well, yeah, I mean, by all means, you could in fact do that. There's nothing stopping you from doing that. But, well, it does not change the fact at the end of the day that the crit damage coefficients, regardless of the order you put them in. So for example, what did I take? Well, I decided to take the 5.4 and change it to tier 3. So let's go. There it is. So there's tier 3. So now we have 7 like this. And now it's like this. So it doesn't match up as cleanly, but by all means, if you can still factor a 2 and you will still see all of these coefficients in here, and the overall crit damage and crit rate doesn't change. It really does not change. What matters is that we have these integers and that they correspond to a specific value from the different tiers. So it doesn't matter what we define tier 1 to be. It could be 2.7 and 7 for all we care about. These are just the values we observe in the game. And well, in this case, so why don't we just run through the logic over around here? So we have this, and so we took the 2.7 and we decided to swap it with this 3.5 here at the front. So yeah, there we go. So doesn't matter. These values are still ultimately the same, even though they don't match tiers. You know what, I'm just gonna run through the entire thing again, and with a different crit value and everything, and I hope you will be able to follow along. So let's go ahead and do it. I'm gonna copy everything, paste it, then I'm going to just decide to swap around these values, because why not? Yeah, I'll leave it like that, because everything else, or you know, why not? We'll swap these two as well. So we now have different tiers, and oh, this one's still 2 times something. We'll do this. So yeah, nothing has any more rhyme or reason. So yeah, let's go ahead and write out everything again. So we have CRI, and then for the first tier we have, well, it's still going to be CV1. So that's nice. So that's still CV1, and then we have MR1 I. Let's do this now with CD2 or CD. So what do we have in tier 1? Well, we have 7. So we already know that these quantities here are 2 times something. So they are still related to these CV values, by the way. So then we have, well, this is going to now just be CV, what was it? 3.5. Yeah, CV 3 to 3.5, which is it's that. MD1I. And I'm just gonna do this for the rest of the tiers, by the way. You can see here that despite, you know, despite all of this, you know, CV1, the CV1 is not matching with the CV3, even though we have MR1 and MD1, it really does not matter that that is the case. What matters is the fact that these quantities, all of these quantities are related to these quantities in some way. And because this 2 can be factored in to every single individual term here, it doesn't matter. The only thing that changes is which quantity goes up or down depending on which tier is selected. So let's go back to our Genshin example here. So in our Genshin example here, we have this 6.2. So that's pretty cool. I want to compare the 2 different tiers. So, you know, in the simpler tier, well, that just corresponds to a tier of 2 for the crit damage. So that would specifically mean that in order to get 6.2 in our crit damage, we have to specifically increase this MD2. However, if we decided to use this much more random and probably more general type of tier system, well, you know, we have a value of 6.2, well, that would just mean that I have to choose MD4 rather than you know, MD2 here. So we can essentially just hide all of that complexity of what's going on in the individual crit values, or what's happening with the selection of these different minor affix values, by essentially grouping them up into a single quantity, which I call n. And that is the relationship of these equations. And notice again, it does not matter how I arrange them. It does not matter. You will still ultimately get a relationship that suggests that CRI is equal to NRICV and CDI is equal to 2 times NDICV. It does not matter. That is simply a fact because of how the values presented in-game are related. So hopefully to Lewis Who 8214, I hope that answer is satisfactory. It is a very complicated question, and I actually really appreciate that you left it for me to answer. Granted, I'm sorry that I had to do it into a video, And I had to do it into a rather complicated manner where I had to literally model the system of artifact upgrades exactly as it is in game. But again, we can hide all of that complexity under a bunch of stuff. And in fact, you know, because you know, this whole system where, you know, you start with M's simplifies to the case where we have the NRIs and ND. This can actually go back all the way back to this very simple proof. So this proof is completely valid. Granted, it just requires you to justify a lot of things. So yeah, I hope you guys enjoyed this video. I do have a second part planned for this follow-up video, mainly because I think this one is getting a little long, and I'm trying not to create feature-length films every time I upload, so yeah. One of the things I want to cover in that video is the importance of the constraint, which is NR plus ND is equal to N. I think some people still don't quite understand why I want to emphasize it so much. And yeah, there are some people who do have slight misconceptions. I won't call them false, because they are pretty well justified, but it's also important to consider what the constraint means. I also have plans to show how to account for the fact that, you know, crit rate should probably not go more than 100%, just a thought. And, you know, that's also just something you really actually would want to do. You know, make sure that people don't go over 100% crit rate. And regardless of that, those are the main two things that I have off the top of my head. I don't know, maybe when I actually go to record it, I'll remember something else, and then, yeah. If you like the video, make sure to like it, share it, comment, you know the drill. You could also become a channel member, you know, get some awesome perks. And like Eternal Dongo Work, who has been supporting the channel for quite a while now. A very, very, very big thank you to you. And, well, yeah, a very, 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 very big thanks to all of you who have watched the video. Again, I really cannot express how grateful I am that you guys liked the differential calculus video. I don't really have much else to say, so that's really about it for now. So thanks for watching, and hope you've enjoyed.